We have a nice car now, going around and obeying all kind of rules. But the car just goes around forever. Usually they go somewhere. So we'll experiment with adding a kind of a compass sensor that tells where the target is. Now, spoiler alert, this compass approach is not great. So I won't insist on it too much. I just want to get something that kind of works, so you see it's not enough in practice, and why we'll need to study pathfinding algorithms soon. Speaking of which, I'll have to show you how to update the self-driving car code base to load the cars we make in this playground, and also how to get it ready for pathfinding. About time we get back in the code saddle. Get it? Because we haven't coded since. No, 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 no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Start the playground from the link in the description, and you're going to get this scenario that also has a target. The car has 3 sensors this time because we're going to teach it to turn left or right depending on where the target is, so it's going to need to see on the left as well. And there is another sensor that is not really displayed anywhere, but you can see it here as this node. This value here tells the angle that you need to turn to face the target, kind of. It's not really an angle, it's again a value between 0 and 1, but let's check it out. So I'm going to turn on this manual override, and hovering this, you see there a value of minus 24. This just means that you have to turn left. Minus means left, and positive values mean you have to turn right. So now you have to turn right 25%. And then you would be facing this. So a 0 value means that you're pointing exactly at the target there. And if you're going to go all the way like opposite direction, then it's going to say minus 1. But as soon as it's more convenient to turn right, you're going to start getting positive values there. So 1, essentially. And it's just telling you that now the car should turn right so that you turn to face the target. That's what this sensor says. And really, it's kind of like a compass. If you look at a compass, then you get the same information from that as well. Many devices have these kind of magnetic sensors nowadays, including smartphones. Okay, so with this setup, let's try to make the car head to that target. And I'm going to start by cleaning everything. And we're again going to work with some components here, like last time. So let's move now this up sensor and the speed sensor here and put the reverse in this top left corner. And now turning left, turning right, and it's going to use these sensors here, the left and right sensors, and it's also going to use this one, but let's set it aside for now. The logic we'll implement here is going to be really easy. I want just the car to move somehow and control the steering based on this other sensor. It won't be anything nearly as polished as what we did in the last lessons. I just want to give you the idea how you might do such a thing. And let's do the simple logic for moving forward. So let's focus here on the speed and the forward sensor and make that slope appear there. So -1 and -1. And here we're going to set -90. And this is going to be just the opposite. So I'm going to put here +1, +1, and positive 90%, like that. Now if we restart and turn off the manual override, we should see the car going there and stopping like that. Good. I'm going to turn back manual override and move the car down a bit like this. And let's implement steering with a similar logic as here. For that, I'm going to put here this sensor and here this sensor. So we are focusing on that. And let's connect this one here with a -1 weight and a +1 here this time. And now here we are going to use +1 and -1. So we get this very simple looking structure here. And what this does really is now the point is here, so the car wants to turn left. And it's essentially trying to balance out the ratio between these. So the end result is going to be that the car wants to line up in the center of the road most of the time. Let's try to see how this works. So the car is in the middle of the road, and now these are equal, so the car doesn't decide to turn at all. It's really perfect here how equal those values are. Normally you don't get something like that. Let's turn off this gray and green so that there is no blinking happening and see this again. All right. And now let's see what happens if we add a bias here. So we're going to add a bias, maybe 20% here for this one and -20% for this one. And this is going to mean that the car wants to turn right here and it's going to prefer the right lane actually. Let's try to restart. And now you see the car keeping the right lane there. And then at the intersection, it's steering left because of its initial position when entering the intersection, its acceleration. And actually at the intersection, if you look here, this point is somehow going a little bit crazy. But anyway, this kind of configuration means that the car tends to turn left at the intersection and not right. And if you do the opposite, like put here -20 and here +20, then the car wants to drive on the left lane, and here at the intersection what's going to happen is that the car is going to turn right in this case. And it actually does a pretty good job even with this very simple logic here, but fails at the end because this proportion here tells it to turn left. Anyway, this is not important. I just wanted to get here some logic that actually works and decides how to turn at the intersection, currently based on these biases. But we're not going to use those. We're going to use the value of the sensor instead. So I'm going to put here 0 and 0 as we had before. And let's move this one here because it's somehow a natural place for it to sit. And here I'm going to connect this one with a positive weight, let's say 20, and a negative weight here like so. And look what happens here. I'm gonna turn on manual override, refresh, and now I'm going to move the car somehow here as center as I can. There. It's not fantastic, but anyway. And you see, this falls into the red region now because of how this target is influencing. The car has to turn to the left, so it needs to now turn right so that it's on the right lane for that turn to work. So if I'm going to turn off the manual override, then the car is going a little bit to the right and then is able to manage that left turn. But if you change this link to TGT_1, Then there's a target on the right, and the car is already doing crazy things there. Let's see this again. So the car turns to be on the left lane and prepares for the turn to the right. And then it continues to do some things here, and it is affected somehow by this target still. Like you can see that it starts on the left lane, but after passing this, it moves mostly on the right lane because now the target is on its left. So it's still preparing to turn left to head back to the target, but it never gets another intersection to try. Anyway, this does work to make the car turn in different directions according to where the target is. But it's not always a good solution. Like if you go here and put TGT underscore 2, you see the target is now on the left. And the car is going left at this intersection because it's where it thinks the target is, but it has no idea of the road structure here. So this is a big problem. We either have to teach this road structure to the car, make it part of the neural network somehow, a lot of inputs, weights, biases, very, very complex stuff, or rely on some other solution that gives us the path to follow. Go up here and type S is equal to SP for shortest path. And you're going to see very different things here. This logic is not the one we were playing with now. It's actually the one that teaches the car to do the right-hand rule that we played with previously. And that target, the compass sensor, is completely gone. So the car is just exploring here, this maze, and nothing else. But there is this added button here that tells the car to follow a specific path. And let's try restarting this and pressing this button. And it's going to obey now this corridor that appeared here. So these lines here that you see are going to be new borders that the car is going to try to listen to. This corridor is the shortest path from where we press the button to where the target is. And you can actually remove it and press it anytime you want, like now, and see what the car is doing. We just told it, go to that target, and it's doing it. It's going to that target no matter where it is in this maze, so to speak. I'm going to teach you how to implement this algorithm for finding the shortest path between 2 points in a graph. But for that, we need to take this brain back into our code base from the end of phase 2. So we're going to need to set things up a little bit there, and in the next lesson, we're going to implement Dijkstra's algorithm. This part is mostly for those who followed along with coding the self-driving car simulation and want to get the full connection here. If you just want to learn about Dijkstra's algorithm, you can skip this part. I'll post the new code on GitHub, and you can take it from there before the next lesson. This is the code from the end of phase 2, and index.html looks like this. There are many cars there in this simulation, and they're trying to navigate this more complicated world. The best one is always highlighted. Now, the first thing we want to do is bring the logic for the right-hand rule here inside of this system. And we're going to go to the code and create a new folder here. We are going to name it saves. And in it, I'm going to paste the car we saved in that one lesson. Mine looks like this. And if we open it, we can see a lot of different things here. It's basically JSON information, and it's stored inside of this car info global variable. The only important things here really are the max speed, the acceleration, and the friction, because they have different values in the playground than in our code base. But also the brain, Let's see where that is. Not these, but that one. So the levels, the inputs, outputs, biases, and the weights, we have to load these from here now. And the sensor is also important. Like the car here has 5 of these ray casting sensors. We have to use just 2 of them at the right angle and with an offset. This system doesn't yet support that, but it's an easy fix. And we have to include the speed of the car as well, right? So a little bit work to get this to work exactly like in the playground, but it's not very complicated. The sensor values are here as well. This ray count, ray length, ray spread, and the new offset. So let's go back to index.html here and load the car just here beneath the world. So it's going to be included like a basic JavaScript file, right-hand rule.car. The extension is just to mark that it's a car file. And let's save this and go inside main.js, close this, and go to the place where we generate the cars. So there is this generate cars function down here. And we want the car to load the information from inside of that car info. I'm going to say here car is equal to, and let me copy this from here. I'm gonna cut it here. And this is going to be what we push inside of the cars array. But before that, we will say car load the car info like this. And this load function inside of the car object is what we need to implement. So we go here, and below the constructor, we just have to type load given some info. Let's set the brain to info.brain, and those properties max speed, info, max speed, friction, info.friction, acceleration, info.acceleration, and the ray count from the sensor, from info sensor ray count. And we have to do this for the ray spread, length, and offset. So I just copied this 3 more times, and this is going to be here ray spread. Let's copy it here. Ray length. Let's copy it here. And ray offset here. And this offset is something that the sensor doesn't support at the moment, so let's fix that real quick. They are all made to be symmetric at the moment. So here I'm going to say this array offset is equal to 0 in the constructor by default, but it can be assigned something else if we load it from that file. And when we cast the rays, this is the important part, we need to add that offset to each individual ray angle. So here I will say plus this ray offset. And we're almost done. The last thing we need to do is set the speed as the last input to the neural network. So in car.js, where we update here, we get these offsets as inputs, and that's just fine. But here we also have to add the speed at the end, and we can use .concat, and it has to be an array that we give here. It's going to be an array with just one element. So the speed, it's going to be a normalized value of the speed. So we take this speed and we divide by this max speed. so that it's going to be between 0 and 1. And if we save this and test, we can see here the network working. It's the same thing that we have in the playground, but visualized a little bit differently. You can probably recognize here the weights and the biases, how they look like. And this is the speed value that we have in the right, and these two are the front and right sensor respectively. And it's doing that right hand rule now. But one thing that you might be curious is, where are the other cars? So we see that all cars are loading this car info. They have the same brain and they are actually overlapping in the simulation. Now here we do have this code that is doing a mutation, but it needs to have something in local storage for it to work. So if we go back and save this car in local storage and refresh, we see that it does now some mutation like that, and it actually gets other cars as well, not just the one that we originally created. Many of these can fail depending on the mutation and how much change has happened there, but it is what it is. And you can control the mutation from here if you want, but I think a value of 0.1 is quite good most of the time. Now, to teach the car to follow a path, to do the path finding, we will have to create a world that has a target. So we're going to go inside of the world folder and open this index.html next. This one should show empty like this, and we're going to start clicking to create a graph that is useful to teach about pathfinding. Now I'm going to start clicking here, and it would be good if you try to follow the same kind of structure. If not, you can also get this world from GitHub. But basically, I'm going to start here like so, and let's zoom out a little bit. So here, if you haven't followed the previous course, we just click to add points and zoom out and use the middle mouse button, the one with the scroll wheel, to pan around. And after doing this, we can create now a few more points. So maybe something like this. Let's also add a new point somewhere here on the right and connect this one back to the start. Now right click to deselect this point and clicking to select this one. Let's add a link also here and a few more of these segments up here like so. So this should be complex enough for teaching about pathfinding. And the starting point is going to be here. So we select the car and we click here at the bottom somewhere where we want the car to be in the very beginning. And the target, this one, is going to be all the way here at the top, somewhere here, like this. Now, when saving the world, it's important to choose some good position to start at and maybe the zoom level. This will make some things easier later on when testing. So maybe something like this is what we're going to see at first. And let's save this. I called this pathfinding, and you can find it here, pathfinding.world, in the saves from the world folder. So we have two different saves, one for cars and one for worlds here. Now to load this new one, we go to the index.html from the root, not inside of the world. So this one. And here, instead of including this big world, we are going to make a copy of it so that I remember that big world exists and include the new one, so pathfinding world. Now, if you save this and go to our car simulation and refresh, you're actually gonna get an error. Turn on the developer tools and you'll see this kind of errors here. And the reason for these errors are here in the way the world was saved. So pathfinding world is just a JSON object, but big world has world is equal to world.load, and inside of that function we have the JSON object. And it ends with this parenthesis and semicolon. You could add these manually to that, but I'm going to teach you how to make the world editor to save in this format because it's more useful, I think. So inside of the world project, we open index.html and we look for the save function. So the save function is here and it just writes here the stringified version of the world. We are going to change this a little bit. So we are going to say here like this. And now we stringify here like that. And then we close this. And now save this file, go back to the world editor, refresh, and press save again. Overwriting the file is just fine. And if you look now at pathfinding.world, it does start like that. So we made this so that we don't have to do any manual editing anymore like what we did in phase 2. And if we go back here and refresh this page, we can see now the cars going in this new world. But before we check things out there, let's also fix the load function inside of the index.html from world. So what we need to do is go to the load and here prepare to cut out the extra strings at the beginning and at the end there. So I'm going to go here above this JSON data and I'm going to take the JSON string first from this file content, and I'm going to take the substring like so. And starting at the index of the first open parenthesis, +1 because I don't want to include that parenthesis, and then ending at the last index of the close parenthesis. So basically taking the same thing that we had previously. Otherwise, loading worlds will not work with this new format. We just need to take this JSON string and put it here instead of the original file content. Now, if you save this, go to the world editor and refresh. Now load, for example, the big world that we already had there. Something crazy happens, so it's still not perfect. If you zoom out and go down a little bit, you can actually see that that other world is there. But if you open the console, you'll see that there is an error happening. And this error is because after this world is loaded, it's set into local storage. And that part fails. This world is too big to fit into local storage. So we're going to implement the same solution we used to load the world in the simulator. Let's remove entirely this load function from here. And at the top, I'm going to also remove this button for loading the world. Instead, we are going to go at the bottom and add a new script from saves big.world. And this is going to load the world in the same way that we had previously in the simulator. But we need to take out from here these attempts to read from local storage. So all of these things can be removed. Like so. Now if you save, it works. But there is one small problem with the code, and that is that the roads here at the roundabout are supposed to be one way, and there is a mistake I omitted last time. So to fix it, we have to go in world.js here and see where the loading is happening. So here we load the graph with this function, and this is where the problem is. So we actually have to open math, graph, and load. And here the segments are just loading what is P1 and P2, but not also the information if this is one-way road or not. And we can fix that by typing this here and saving. Refresh, and you're gonna see that the lines here look different because they are supposed to be one-way segments. It's a small thing, but really important because I'm gonna teach you about pathfinding, and we will have to take into consideration one-way roads as well. Now, maybe we want to have a target in this world as well, to have a more realistic scenario. This is my hometown, after all. So let's add the target here and figure out a nice zoom and center point, maybe here where the car is, and save this new world, big with target. Let's go to the index.html from the root, so not inside the world anymore, and add a way to include that one as well. I'll comment out the pathfinding for now, and this will be big with target. Save and go to the simulation, refresh. And now it's loading the big world, hopefully with the target. Let's see. Yeah, you can see it there in the top right. Okay, so this is what we're going to be using to study about pathfinding, but we will work with this pathfinding world to begin with. It's easier than the big one we just created and helpful when explaining how the algorithm works. So let's make sure we have it here and also load it by default in the world editor. Let's add these other ones for reference. Save and refresh, and seems to work quite well.